Hello, and welcome back to another episode of Common Sense OT Security. And in today's episode, I'll be talking about systems modeling and showing you some things that you probably haven't seen before or seen done inside of a automatic OT asset management system. So let's kick things off with something that trips up a lot of people, especially if you're coming from the IT sector. And that is in IT, we tend to think of things in terms of devices. That means servers, switches, IPs. You just gotta secure those devices and secure the data that's attached to those devices. In OT, that whole idea starts to break down. And that's because in OT, the thing you're actually protecting isn't the PLCs or the data, it's the physical process. You see? And OT engineers don't think in devices at all, like we do in IT. They think in systems, and these are the functions that exist in the real world. Now, a PLC on its own doesn't do anything in the minds of an OT professional. It only makes sense in the context of the system it belongs to. And this is exactly what OT systems modeling is all about. Now, let me show you what I mean by this. All right. So you see with the other guys, you get a device list that's similar to what I have here. It's it's necessary, but fundamentally it's insufficient. And here's why. In OT, like I said before, they think of things in terms of system and not the individual devices that we have on this list. So just showing them a list of devices, they'll just be like, "Oh, okay, I guess that's good," you know? So in OT base, we allow you to inventory your devices, not only inventory your devices, but also the systems that they belong to. And this is key because it provides context. Let me show you here. So if you look right here on the left hand side, we have devices and then we have system. Now this separates what we do from the other guys that's out there because we have that knowledge of OT. So clicking on system, the first thing you'll notice is that it's hierarchical. And that means, we try to follow the ISA 95 spec where, we just list things out so that, when control engineers see this, they automatically understand, oh, okay, I understand what's going on here. Now, the only thing about this is that it's not automatically generated. Why? Because OTbase doesn't know your setup. So you have to provide some input, some manual setup here that, OTbase can take and then model your relations from it. Okay. So one thing I also want to point out is just because, well, you know what? Skip that. OTbase gives you the means to, set up the the system relations and the system modeling, even though it can't generate it automatically. So one thing I want to show you to start is that we've got some systems already pre-set up in here. And I just want to pull up what I call the Mickey Mouse model because it's very minimalistic, just so you can get an idea of the concept of what's going on here. So this one is an car assembly plant that we just slapped together. And I'm going to bring that up right now. So if I click it, BIW15, and I click relations, we get this nice little diagram that shows us the relations. But as I said before, this is just a Mickey Mouse, high level view that people can just soak in. So here we have a car plant that has, these different systems in there. Now, the thing I really want to show you is that clicking on an individual system brings up all of the devices that's a part of that system, meaning that you can drill down and see all the individual components and devices and networks that comprise this particular system. All right, and along with other metadata in here. But for the most part, we're looking at all the devices and the networks associated with this system. And if you want, you can check out the topology of the system too. So that's pretty neat. But I'm sure the OT guys are just like, yeah, we want to get to the good stuff. Anthony, knock our socks off. All right. So let's jump to a more realistic system that we've modeled. Let's close this out. And let's check out this one. So I'm going to press relations. And the first thing that you can see here is that we have some form of redundancy going on. This particular system, it's modeled after I guess a yogurt filling plant where you have the raw materials coming in. It gets processed at one of the preprocessors. And then from there, each one of these units has a tank, a reactor. And to go back a little bit, sorry, I didn't even add that. Oops, there you go. You know what, let me just step back since I didn't show you that first example. So here's that first example. Apology. Oops, sorry, I'm pressing the wrong one. So here's the minimal Mickey Mouse example that I initially wanted to show you. So with that being said, you can drill down into the different parts of the system model. If I click here, I'm able to see the networks associated with that system and all the devices that's associated with this particular system real quick. All right. Boom, boom, boom. Let's close that out. Now, for the more realistic one, which is the Spartanburg plant that handles yogurt, we start with the raw materials. We model the raw materials coming in. And then what makes this super realistic is that we got some form of redundancy here. We have mixer 1, mixer 2, and then we have the whole section right here. Now, the redundancy really comes into effect when you're doing network segmentation. Because when you look at these, if they're on the same network and something happens, let's say something malicious happens, both of these are gone, And so I'm not able to drill down and show you that because we don't have any real information in this particular demo. But I just wanted to point out that you can easily look at this and by clicking on it, see that, oh, yes, these are properly segmented. And if something were to go down or whatever, mixer 1, either mixer 1 or mixer 2 will, still be able to continue that manufacturing process. So that's pretty neat. And another cool thing that'll definitely knock your socks off is, let's say you don't want this detailed view. Well, you can collapse that so you can have a more high level view of what's going on in here. So just by looking at this, we got the raw materials coming in, they get mixed, and then they end up over here in the filler station, yes, where they get put into bottles. So not everyone wants to see, you know, all the specifics and everything like this, but I'm sure when the OT guys see this, like, wow, you can really do this stuff. Wow, they'll be definitely impressed when they see this stuff because, like I said, I'm showing you stuff that don't doesn't really exist in other products because they just don't have that knowledge of OT. And this pretty much any control engineer seeing this right now, I'm pretty sure they're pretty impressed with what we've done with this platform. And let me show you another one. So that's the food industry with the yogurt and everything. Just a quick modeling off of that a particular plant. All right. So is that everything I want to show you? Yeah, I believe so. And one thing I also want to mention is that you're able to model your dependencies. So for instance, if I go to this filling line, all these smaller units in here are the systems that are dependent on, well, the filler line is depending on all of these bottling cells, the bottle preparation, the bottle filler, and the bottle labeler. These are the internal processes of this system. And like I showed you in the Mickey Mouse example, if there were devices attached to these particular units, we'll be able to drill down even further and see that information. And just backing up and taking a high level view of things, you can also collapse things down and reorganize things the way you want and everything, zoom in and out. And yeah, that's some pretty cool stuff that we got going on when it comes to system modeling. All right, let me see if I could pull up another example. This one is of a power plant. And let's check out the relations here. This one's, again, is more realistic because we have that redundancy. And 10 out of 10 times, these redundant systems are on different networks. Like I specified before, if something were to happen to either one of these, the other one will, still be able to continue that process. And this is the things that engineers, control engineers, love to see. They just don't want to see that list of stuff. They want to see how things relate to each other. And with OTbase, you're able to create that relationship. Like I said before earlier, it's not automatic. It's going to take a little bit of work for you to, just put that stuff in. But OTbase gives you the means to do it, unlike the other guys. So how does that work? Let's say I wanted to add another component to, let's say, this flat rock car assembly setup that we got here. So what I just need to do in OTbase Inventory is just click the Add button. I give that sub process or that subsystem a name, give it an ID, and here's the kicker. We allow you to define how this subsystem relates to everything in this hierarchy, mainly the flat rock car assembly plant. So if I wanted to add the subsystem, I would give it a direction. And the direction is listed out right here. I can either select interacts with, and then the system or the group along with its criticality, or provides to. And this, provides to and consume from. This formulates the arrows that you see inside of the diagram. So if it consumes from, that means it's taking from something else and then doing something in that process to then use as output for somewhere else. So in OTbase Inventory, setting up these systems is relatively quite straightforward and simple. And this is just one of the features that shows you that when it comes to OT-based inventory, we have that knowledge of OT to the point where, control engineers drool over something like this, and it's pretty straightforward, easy to set up. And once you've done your discovery and got all your devices, where we allow you to take it to the next level. Because as I said before, control engineers would and OT professionals would just look at the list like, oh, okay, you mind sharing that so I can add it to my Excel file, but this right here allows you to model and show those relations and how interconnected your systems are. And one other thing that I want to point out is the criticality. OT professionals, when they see this, they can just easily determine, oh, okay, this system is system critical, and we can formulate a criticality score for this. And that just drives more visibility, because now they know the critical systems, and then you get that information and you can show that to the higher ups and say, oh, wow, these systems are critical. Here's this cool diagram that OTbase Inventory set up for us. Well, it didn't set it up, that we modeled in OTbase. Yeah. And yeah, it's like I said, it's pretty straightforward. And yeah, if you guys have any questions about this, I'm looking at the chat. I don't see any questions, but if you do, just go ahead and drop it inside of the chat, and I'll be sure to answer it. Let's just give everybody a quick minute just to formulate any questions that they might have. All right. So if you guys don't have any questions, I'll just wrap things up. And I just wanted to say that, yeah, OTbase just makes your job 10 times easier, especially when it comes to creating the systems and seeing those diagrams and everything. So I'll end it right here. And if you guys have any questions, we'll be in the comments section of the screen. Thank you and have a good one. I'll see you in the next episode of Common Sense OT Security. Goodbye.